Iotron invested nearly $6 million to apply computers to critical functions on ships' bridges, mainly collision avoidance systems in response to a MARAD administration industry-wide requirement in 1960. The other product was a fuel-saving autopilot, which is important now in terms of meeting EPA regulations on reducing greenhouse gases. DigiPLOT is a precision automatic radar plotter. It displays its true and relative vectors on either a north-up or head-up display. You're viewing actual operation at sea in the English Channel on a ferry. There's a flashing symbol on a vessel coming down our side. We happen to be on a head-up 12-mile scale with 6-minute vectors. We just push the button to make it north-up. We're going approximately due north. The other vessel is coming down our side, and he's actually changing course. Our tracking shows it. The watch officer just punched relative to verify the collision risk is quite safe. He's coming down our side. The other vessels are shown in TruePlot. Buoys, of course, are shown with no vectors at all. So the true aspect of all the other vessels are what you would see out the window. You can judge aspect numerically by tagging with the flashing symbol on a single ship and reading the range and bearing, its course and speed, and its CPA, time to CPA. You notice the close tracking. We're now on a closer range scale, and the tracking is within a quarter of a mile, sliding down our side. Once the other vessel clears us, you can see he will begin a slow turn around our stern. Extending the vector now from 6 minutes up to 8, you can see we have a near collision of close passing with another vessel who is actually in our way. The point of 6 minutes is exactly the same time when we will be at the same position in the water, which is the true plot of a collision. We are very accurate in the IMO ARPA specifications. The relative course is measured with our radar and DigiPLOT software to approximately less around 1 degree. The specification is only 12 degrees in the ARPA spec, so we're certainly an order of magnitude better than the requirement. That vessel now is sliding down our side, and you'll notice with the heading mark that's in the bearing circle up at the top of the tube is showing we're turning left. We did the safe thing for normal visual collision avoidance. That is, if you steer for where another vessel is now, that is his location as a dot, we in fact have no way of hitting him. We're absolutely clear. We just changed back to a 12-mile scale, and you can see the bright display, daylight display of the radar coastline of England, the Dover area. You see there's another vessel with a very short vector. Remember, we're doing about 20 knots at 6 minutes. That's 2 miles away. He's doing probably 5 or 6 knots, 5 knots, possibly a fisherman, but anyone slowing down, going down our side. There's another vessel just next to us. Punching relative, you notice it's a very close passing for him, but he is in fact slowing speed to allow us to pass. Notice the other vessels all around are plotted. DigiPLOT actually measures every echo in a PPI that a mate would look at to pick out those that he would either manually plot or manually acquire in all competitive ARPAs. Our system analyzes every echo by measurement, compares it, and divides it into ship-sized and larger than any ship could be, which would be designated as extended or land. We don't bother analyzing anything beyond the closest coastline, which is usually shown as a dotted outline with 3 successive radar scans. The other vessel in this case has now stopped. You can see he looks like a buoy with a circle only. We have a tag on him that we're reading the digital readout to the right of the display. This is another another scene with you can see the traffic passing close by, ferries crossing the English Channel, and the tankers going toward Rotterdam and coming from the southeast. Our own ship is always shown brighter than all the rest of them, and if there is a CPA alarm set in, say a 10th mile or quarter mile, with a 5 or 10, 15 minute, half an hour warning, you will see them brighten. You'll get an audible sound, which can be silenced, but a flashing red light is shown on the instrument, and the ones that violated it are shown brighter than normal. Here you can see this other vessel is picking up speed, and his true plot is shown, again, very much in the same position as our own. We are now turning to avoid, and you notice the accuracy and the other vectors are maintaining their own course and speed properly to the much better than IMO ARPA accuracy. Every now and then the mate will touch the true relative vector button. The glance at relative shows the threat of collision and ranks them as though it were a dartboard, with your own ship's symbol being in the middle. Anything pointing directly at you is going to either hit you or be close passing, either ahead of you or behind or astern. Here now we see essentially a triple collision. We're turning left into one, and there are two others that are threatening. We're turning away from them into the one that's coming directly at us. At 6 minutes, we'll both be at the same spot. The radar is scanning approximately once every 3 seconds. You can index the vector length in minutes, in 1 minute increments, to assess the collision exactly as it is later. This is a built-in trainer, trial maneuver. Your own ship is in the middle going southwest. We've got the tag on a close passing vessel, and all three of those are within a quarter mile within 30 minutes. This shows some channel separation navigation guidelines stabilized by satellite LORAN for the accuracy and the dependability. This shows the recommended route of our ferry going from Dunkirk, crossing the channel at right angles, which is the recommended IMO passing. Pushing the button for trial course on the line properly, crossing at right angles, you see our own ship moving at 30-to-1 speeded up time, and all others are moving the same way. So it shows the exact time of execution for a crossing on the course we want. This also would apply to a land intersection, such as the Concordia. Had they been trying a trial maneuver several minutes ahead of time, they would have seen that the actual trial maneuver, or the actual maneuver they made, would, in fact, with the advance and transfer of the Concordia, run aground as it did. You needn't have a collision to get the AIS results. Our trial maneuver, which we've had from the beginning in all 550 production units, has always been in there for ships, and it's only most recently that it was mentioned in G-Captain for the idea of possibly using it for anti-grounding. It's an excellent trial maneuver because most officers today don't get a chance to maneuver the ship much, so they never get a feel for the ship. This restores the architect's worst advance and transfer characteristics into the trial, so it makes it ultra safe and a big safety saving for all vessels. This shows two limit lines which are manually controlled. You can put them anywhere you want, and in this case we're leaving the French shore, and you want to push all the 40 targets, which would normally be the 40 closest, more toward the middle of the traffic lanes. So as we approach them, you can see it. As we're seeing here, when they first are acquired, all echoes show up as a circle, indicating they're stationary. If they're moving up to a couple of knots, they quickly develop a vector. This way, we are very good at separating out slow fishing vessels at 3 to 5 knots from stationary buoys. We also track without vector swap, as you can see, as new echoes are acquired and plotted and so forth. And we track, the tankers are being tracked even though they're very, very close and overlapping with almost any other ARPA's tracking system would be involved with vectors that would be nonsensical. The lines are completely adjustable, and the acquisition is within approximately a minute. Certainly by 3 minutes, they're fully there to full accuracy. This again, this shows the French coast shown as a radar image. It could easily have been just dotted for the closest coastline. In that way, the vector and DigiPLOT output can be put on top of a current E-chart as a closest coastline outlined by dotting, rather than spraying radar imagery all over the chart so you can't even read it. That's a requirement of the XS design requirement, and our approach fully meets it. Here you can see one of the vessels over to the side is showing a speed up. The dotted circle around own ship is something that's manually put in. It limits the acquisition range. That's because frequently a watch officer doesn't adjust the anti-sea clutter well enough, and there would be some swapping or false echoes acquired there. This means we don't acquire at all automatically inside that dotted circle. You can see the separation of the tankers going toward Rotterdam, all going about the same speed. The limit lines are shown also. Occasionally you'll have a buoy or a vessel that will be right more or less on the line and partially acquire. We require at least 6 positive results of the echo scanning to acquire. But if we will hold tracking, if the repetition is only 1 echo in 10 scans, we will hang on to a very weak echo and give you a very good plot. The bearing ring is shown 360 lit so that it's viewable at night, and of course in the daytime, no problem. We will separate the tracking as long as the echo is not completely merged. If there is echo separation, we will independently correctly track as we're doing with the 2 tankers down at the lower left of the screen. You can see the limit line being adjusted. That forced a couple of more echoes to be in the scanning region. So in 14 minutes, you've had essentially the same training that you would need, which is to operate is certainly no more difficult than your kid's Xbox.